I paid a grand total of £45 for this faulty Nintendo Switch Lite that I bought from eBay. The listing on eBay states, faulty Switch Lite, coral pink, bought as salvage and will not turn on. The more I look at this Nintendo Switch Lite, the more I think I may have wasted my money. On the face of it, it looks alright, and this was the picture on the eBay listing. It basically showed this in a box and, you know, it looks okay. Then I saw the state of the USB-C port on the bottom and I thought, you know what, maybe it's just a faulty USB-C port. We can get that changed out, no problem. Then I tilted the console up and noticed there's no volume or power button. The plastic is gone. We're missing a screw here. We have one screw here, but it looks like the wrong screw. And also we've got a random silver one. Usually this screw is black. So again, a different type of screw has been put in on the case up here. So I've no idea what I've got myself into. And like I said, I'm not going to plug in the charger, and that's the reason why. Clearly we can see a lot of damage to the USB-C port. The pins on the bottom side have been really pushed back. Whether or not that's actually caused damage to the M92 power IC, it's definitely looking that way, if I was to take a random guess. But let's get it apart and see what we're looking at. The more I look at this, the more I think it's actually had a shell swap, because all of the screws on the side here are Phillips and they're meant to be tri-wing screws. But I'm sure that pink coral was like a normal colour for a Switch Lite. That's why I'm a little bit confused. The other possibility is that someone's tried to take it apart to repair it, not had the correct screws, and then used other ones. Initial signs, actually it looks fine. There's no water damage or anything like that. Actually looks like a pretty clean board. Okay, I found hazardous trip over number one. The clasp for the fan is missing, and somehow it's ended up, where is it? Have I lost it? Down here. How? You see this little thing down here? This is the clasp for the connector. Let's take it apart some more. Okay, first look, we have the HDMI port, and do you know what? There's a lot of flux around this area. I'm going to go ahead and assume that this has been changed before. And to be honest with you, it doesn't even look like a Dremel job. This looks like a port that was purposely bought for the Nintendo Switch Lite, which I know they're quite expensive as well. And if we check the underside, yeah, you can see all the flux. The soldering job isn't amazing, but clearly it's worked for the time being. And then again, if we look on the inside of the port, you can see how damaged it is. You can also see here, there is a solder blob. Maybe that had a part to play when they were putting the charging cable in. That's what's damaged the ports, because it's knocked over the cable. I wonder. I think first things first, let's get this port off. We're going to go 450 degrees Celsius with an airflow speed of 50%. I'm actually looking forward to see how easy this comes off. See all the flux. I need to put the extractor on. Right, that port did not want to budge. Need to be quick whilst it's hot, give it a clean. All this nasty flux away. I'm going to clean up the solder we have here, because I don't know what solder this is. I don't know what flux this person used. So we're going to get this all clean now. There we go, just cleaned out all the ground holes. As you can see, here, here and here, using the solder sucker, nice and easy. Take the solder off these pads, and then we're going to fill each pad with leaded solder. A little bit of flux just to help. Now we're ready to drop the port in. 450 degrees Celsius with an airflow speed of 30%. This is to avoid the charging port flying off the board when we're heating it from underneath. And release. And let's check our work. So here we have the pins. I take a pair of tweezers and I check. Every single one solid. There we are from that point of view. Now I turn it around. That's what we look like from the back. Give it all a nice clean, nice on the back. And we're looking to have a really nice finish here. All I would say is that the solder hasn't really pushed through too much on the ground holes. I mean, the port is absolutely solid, but you know, just for that extra protection. So what I'm gonna do is just put a little bit of flux on the back here and see if I can push these through. I mean, it's made a difference to the front two, as you can see. But the back two not so much. Just see if I can put a bit of flux down here. See if I can strengthen this one up a little bit. So we've got these front two, we've got this one. This one again is a little bit weaker. I mean, on the underside, it's absolutely fine. And this one now has some strength to it as well. So we are looking relatively good in my opinion. Next, we quickly need to sort out this connector here. Don't think we're gonna be able to put the plastic back in, so I'm just gonna swap this connector for another connector. I was just thinking before that, actually, I should test the charger port to make sure we're all good and that the device works before I start changing out other components that don't matter as much as the power. So we have our port here. Let's plug in the ammeter. This reads it, and we have good signs. We have 15 volts and 0.25 amps. That's okay. We haven't got a battery plugged in, so that's fine. Let's switch it over and see if we get the same on the back. Do we get the same on the back? If we do, successful job. 14.8 volts and up to 0.25 amps. Perfect. Let's carry on swapping out that fan connector. Right, let's take off the connector from this board. We're going to heat from underneath to remove it. This is the bad one. We're going to apply a little bit of flux and a bit of solder. There we go, nice. And now we should just be able to take our replacement connector, put it roughly in place, and it should flow down nicely. Go with the same method of heating from underneath. About there will be fine, it should flow. Same sort of temperature. So we're going 450 degrees Celsius, airflow speed 50% from underneath the board. I think we're okay. I'll have to test the connections and stuff, but I think that's alright. Okay, are these pins solid? Yes, they are, every single one. That's good. Yeah, the solder's gone right up there, which is nice. Check that side as well, just at the top. Yeah, perfect. Okay, sweet. Before I go ahead and turn this on, I think it would be silly of me not to test M92T36, because I should have done it almost at the start when we removed the port. Because of how mangled the port was, it could have blown M92. So let's check for shorts. Start with this cap down here. That's good. Oh, I don't know if that's meant to be shorted or not, this one. So I'll bear that in mind, that this one's short. These three are the usual culprits. They're fine. These three are fine on the left. This one's also fine. CPU cap? No! No! I'm pretty sure that that cap being shorted means that the CPU is dead, and I've potentially wasted a lot of time doing that port swap. I've wasted the port where I could have checked that as soon as I took the port off the board. That was actually really, really silly and stupid of me. We will learn from our mistakes though. This is a donor board and this is the cap, and as you can see, it's not meant to be shorted. This doesn't work because of severe liquid damage, by the way, but this cap should be all good. And this one down here that was shorted, on this being the donor board, isn't shorted. I'll try and remove both the caps on the other one, which is here, and I'll see if the short goes. I'll also take off M92T36, because why not? But I'm pretty sure it means dead CPU. Wait for it to cool down. Give it a bath. All right, let's see what happens now that we have the components off. So this area here will be ground, and the CPU cap, yeah, it's still shorted to ground, look. And this one, the short's gone. Oh, I took off the wrong blimming cap. Let me take this one off real quick. Okay, let's see now. What do we get? Ah, still shorted to ground, this cap. So this is shorted to ground, and we have the dreaded CPU cap, which is also shorted to ground. I think we can call this one game over, unfortunately. You win some, you lose some, but today, unfortunately, I definitely lost. If you'd like to see more videos of me trying to fix Nintendo Switch Lites, I'll leave a video up here. Thank you so much for watching, and I'll see you in the next one. Peace.